Hello everyone, my name is Anuj and I'm the co-founder of FORMCEPT and one of the talks that you heard earlier with Aldo. And at FORMCEPT, my primary goal is to be the chief architect, and I have been designing this data systems for almost 16 years now. And this talk primarily, what I decided is I will take you through a journey of how we have worked on different data models while working with different clients, different companies. And it's like I've worked very closely with the team with more than 70, 75 companies. And we have seen that how they have been managing their data over time. And this time is like starting from the Hadoop of the worlds, like starting from 2011, 2012, and the entire journey till now. And what I would like to mainly cover is my experiences while working at FORMCEPT and with these companies. And I will try to communicate the key learnings that have been there so that you can also adopt some of these and see if they work for you and hopefully have a better data model or data platform in place in your company, organizations, or any libraries that you're working with. So before I start, now these days whenever I go to any of these companies, right, everyone says, do you do AI or not? So I need to have this mandatory slide on AI. And but I would like to tell all of you that all AI problems are data problems, at least at first. They start with these data problems. And fortunately or unfortunately, the enterprises have taken a leap and all of them are now AI ready. So if you go to their websites, all the enterprises are now AI ready. But if you go and talk to them, they are still not data ready. And I see that as a very big issue. And the people who have been using our platforms are realizing that they need to be data ready first before they can talk about being AI ready. And there is a change in terminologies as well. So people whom I spoke to 5 years back, they were in the data team. But now when I speak to, all of them are prompt engineers. So there is mismatch there. So I don't know whether they were the right data guys or they are the right prompt guys. And you would have heard about large language models. And I was talking to my professor some time back, and he's a very old guy but very sharp. And he said that, Anuj, tell me, they talk about large language, there is a language in there. Then how is it going to solve the data problems that you are talking about? That we are not linguistic programmers, right? So how is it going to solve it? So that really hits you. And when you think about it, if you follow the entire this large language model journey as well, it started with one very good thing, that was generation and very good understanding and comprehension of languages, right? And it works best for that. But now what we are doing is we are forcefully trying to prompt it to do certain things, and we are trying to literally rag it and say, that's all my data problems, because we know you can do lots of different wonders. But one thing that is missing there is the domain model, or the data domain model that I'm going to talk about. That's going to make all the difference. And same thing when we use LLMs in our platform or we try to adopt it, we have seen what a big difference this kind of data model brings in. So if you look at this entire world, when you go and go to any companies who are adopting your product or libraries, you talk to them, all of them want to build a very sophisticated analytics or AI application that can skyrocket their sales. So that's a discussion that we'll have. And it all looks very good, right? All of you want that, right, to succeed. But if you go back and talk to their team who are going to implement this or going to talk or build this, the requirement that there is. So you always will have these questions. Do we have enough data? And if you know that you have data, the next question is, which team has it? Which database has my user details or product details? and which field in that particular database contains my user ID, for example, right? Once you have all the databases, the next question is how do you connect them? You will find different teams connecting the same database in a very different way and giving you a data that's is in entirely different shape. And once you have figured out everything, you now have to build certain data flows, right? Data pipelines. So you go and look for those data engineering teams who can build this entire pipelines for you such that you can get your data. And eventually you want to do AI, right? That's how you will get the skyrocket sales. That's how you'll get the thing that you need. So you need certain kind of a single view on which you have very nice machine learning model that can run on it, and it should have all the features that you need, and you want to run that model and it will give you very interesting results. But for that you need this single view, and to get that up to that level is the entire set of challenge that companies are facing. You would have heard about this thing long back, 10 years back, 20 years back, people talking about data, and I tell you still the problem remains the same because we are not giving enough thought to these models. And even if you know about these databases, right, and this is all, I found this image, but this is what I have experienced personally, that I went to these teams and asked, why are you building this entire pipelines separately, right? Why are you building again and again? And if you look at it, what will happen is some engineers who have taken a call to define a user ID as user underscore ID or UID or user ID like that, it impacts the entire implementation that they have done. So if you have this data team, they can be lawfully good or they can be chaotic evil, and that decides the data model that you are going to have within an organization. And once you have this, you will see that half of the team is only stitching things, right? They will stitch for one particular application, they will prepare the data, very good, it takes 6 months, 8 months, and then your job is done. But again, the next application comes. And again, you build the entire flow again, entire stitch it again. So this process continuously repeats, and this entire effort that you are doing, that is where you will see that people say, no, data analytics projects are delayed, AI projects are delayed. So all this is the main reason. And one of the things that happens is if you change any data set or any data model at the back, the entire application that you have built, that has a cascading effect of everything that you have built on. So imagine having two applications, one is using UID and user underscore ID, the other application, and you have to merge it, right? It's a big deal. And when you build these kind of models in isolation or these kind of pipelines in isolation, and in very large organizations, this team will not even know about it, what they are building, right? They will have entirely isolated teams. So if you are building like that, it's very difficult to validate against any intended domain model that the business is thinking about. So the reality of the business is nowhere closer to the data models or different data models or very data models that the company is having. So what we can say is that there is a significant gap in between the business domain that the business is working on and the underlying data model. And why there is a gap is, suppose if you are a company like Uber, all the data that you can capture, you are only interested in those pieces of data that talk about your specific business. Like you are interested in some driver information, rider information, rights information, routes information, different transactions, right? If the data is not talking about any of these, it's not at all relevant for you. So why to have that gap within your organization? Why to have that siloed approach? And why to go with an approach where if I ask you that, can you tell me what data you have or what kind of data sets you have, you really struggle to reach out to the teams to find one single source of truth of the data that exists within the organization. So if you look at it, the goal is the same. All the teams are working towards the company's goal, but unfortunately they are at the different ends of the rope. So if you look at, I hope that I'm able to frame the problem that exists, and what we came up with, and it's like a journey towards reaching this space, is how you can arrive at a certain unified data model, or how you can build a certain flow within an organization that helps you to achieve a single source of truth. And this is like a secret sauce that I'll talk about, but as I'm talking about, you will definitely understand and relate to the, if you are working on this space or different data sets. So first question that we asked, and that why do we always talk about databases? Any project that you want to do in this space, you always talk about databases, right? Should I create one database? Should I create two databases? Should I create user database separately? Should I create transactions separately? Right? So whether it has to be a single database or n databases, that question you need to ask. Right? Why are we doing like this? And we have good enough advancement in the technologies that allows you to think of having one single database, or just forget the concept of database at all and think about everything as one unified structure. And if you think about multiple databases, the next problem that you have is how to connect them. So we ourselves are creating different databases, and then we ourselves are trying to connect all of them or stitch all of them to achieve a certain goal. So the data connectedness that exists within the data is defined by a business. And if you think about it, you will understand that, like Uber example I gave you, that how a driver is connected to a rider is your business. So that connectedness of the data is defined by your business. So that means the data connectedness can be discovered, right? It should not be coded by your data engineers who may not have that level of domain information or business domain information that your executives or CXOs or CDOs, all those terms that have come up, will be having. So the data models should focus on entities and attributes, and this is not a new concept. It has been there, and you would have already looked into different databases like Datomic and all of them now advocate that. And this concept, we thought about it in 2011 when we were working with RDFs, and the entire semantic web concept that exists has this as a subject, predicate and object graph that they used to build. But that semantic web is a very big, they are trying to address the entire world, but if you take certain concepts from there and try to apply in a very smaller business problem, you can get very good results. And that's where this concept comes in. And technology, like I said, it's already there in form of these databases that will help you to implement it. But the main goal here is that your model should talk about entities and attributes, because that is what brings you closer to your business. And you should not worry about storing or managing your data. It's all now taken care by the tech, by the platform, and there are n number of platforms. We have discussed some platforms here also. They will take care about it, right? Take care of it. You should focus on your entities and attributes. And I'll show you one demo also of the platform where if you focus on entities and attributes, anything that you do after that, the data exploration, the insight generation, dashboarding, search, everything can be linked back to this. Because anything that you are typing in or you are searching it, you are already in that context of the business and you are trying to look for. That means it can be mapped back to your business domain if you have defined it correctly. And you don't need any other information to be kept in mind. You don't need to know any kind of queries, query language. All that can be taken care by the team. Now, if I'm talking about entities and attributes, and I'm saying that all the data can be represented like that, so there has to be some kind of definition of a data point, right? That unit that you are going to save within your system. Somewhere you have to save, right? Somewhere you have to use some database. So you have to store that data. How will you store it? So that unit is defined as a fact, and fact is a value that is assigned to an attribute of an entity at a given point of time. So that's the definition, and you would have seen that definition also. Same definition is that of a fact, but here the interesting point is that every data point is a fact. So how do you do that? Because your Data can be structured like these databases, it can be semi-structured like your Excel files, CSV files, it can be unstructured also, like it can be like a blog content or any message like that. So how do you extract those facts? So this flow summarizes that if it's a structured content, you already have record and fields, you don't have to do anything. If you are able to figure out how that field maps to an attribute, your job is done, you can extract a fact. If it's a semi-structured data, there still is a concept, certain notion of records. Either it's your rows in CSV or in Excel, there are rows and columns, you can do that. When it comes to the unstructured data, that's where we have this annotation engine, one of the demo that we saw in the previous talk as well. So that annotation engine looks into your unstructured data. It looks into the knowledge base that we have built at the back. And again, it's based on the concepts of graphs and RDFs and those connections and Wikipedia, DBpedia, all those things we have in the knowledge base. But the interesting thing there is how you look at such a large set and annotate it in sub-seconds. So that's what we do. We extract those annotations, and when you look at those annotations, you will see certain fields, right? You are seeing a text, you are seeing a label, you see a score. So those things now become like a fields, and that you can map it to a fact. So this is how you can extract facts from any kind of content that you have. Now when we talk about facts, fine, data point, it's fine, business domain we spoke about, it's fine. But all your existing applications, right, existing dashboards, existing implementation that you have within an organization, they cannot directly move it to your this business model, right, that you are proposing. I'm not going to go and say that, okay, throw away our database, everything is not required, just use this system. So it's not possible, right? But you need to bring in that standardization within the organization, and to do that you need to have certain model. But that model may not be the model that is directly exposed to all your applications or the external tools that you have. So that's where there is a notion of semantic model and the syntax data model. And these terminologies are coined, and I'm using it because they have a name now that you can go and search for. And there is a book, very good book on data mesh, and they also talk about this semantic model and syntax model. But I'll try to quickly disseminate it and tell you exactly what's the difference is. So if you look at any kind of entities, attributes, and their relationships, we are talking about a semantic model. So this is one of the examples. And all the knowledge that we have, like you define an attributes first, that's only required. Logical collection of those attributes given an ID, that becomes certain entities. So all these concepts are applied at this point. And this semantic data model, if you look at it, you can just look at this entities and attributes, and you will know that we are talking about a certain transactions in the retail world that is happening, right? So that's how you are bringing. I'm just showing you this model, and I brought you closer to the business or the reality of the business that I'm talking about. And if you have these entities, like I said, connectedness can be discovered. If you talk about a transaction, it will have an ID, right? Transaction has to be done by a certain user at a certain store, and they would be buying certain products. So all those connectedness is available. So if you look at it, it's primarily bridging that gap between the implementation, machine implementation that you have, and the person who is looking at that data, right, or that representation. That gap is now filled in. And this particular model itself forms the basis of the knowledge graphs or the knowledge bases that you would have heard about. When it comes to syntax model, this is what we are familiar with, right? It's a flat structures, nested structures, JSON structures, CSV structures. All this, if you look at it, have certain syntactical nature in that. So they are called as syntax models. These models sit closer to your applications because your applications need a certain data in certain structure such that they can work effectively, right? So there are like streaming applications, they need streaming data. There is a dashboard application, right, that needs certain nested JSON structure to show certain graphs. So all those, and then you have to build certain machine learning models, they need a flat structure to work effectively. So all these are your syntax data models, right? But although these two models are different, but they can be connected. They are connected. And how they can be connected is that if you look at the semantic model, it will define your single source of truth, that all the data that you have will be around these entities and attributes. Whereas syntax data model can give you certain structure in the whatever fields you want, in whatever way you want, but it connects back to the semantic model, and it can precisely tell you that this field is coming from which particular attribute of which particular entity. So these two sit very, very closer. So that's how these two models are there. And if you look at it and if you think about it and now go back and try to look at the data sets that you have been working with, you will understand that these two level of models, if you have, and they have their connections, that's a very powerful data model or data structure that you have that can right away track the data from your dashboard up to the level of the business attributes and entities. And this is how I'll show in the platform as well, that we have the entire lineage. So you can look at the syntax model that's very on your right side, but you can track it back to your semantic model up to the source of the data from where it was built. So you have this entire end-to-end automated validation that is not possible when you are working in isolation and without having a certain intended model in place. Now coming to this modeling part, because I spoke about attributes, entities, and how you can get data out of it. So in Clojure, there are different libraries available, and one of the library is Pathum, and I think some of you would have already looked into it or played around with it. So Pathum is a Clojure library that also fits in a similar concept that I'm arguing here of a unified model. So they also try to unify the entire data via the attribute-based concept. And what they built internally is a seamless graph. And there is a nice talk of Ulkal Lucio on maximal graphs and how they built it and how they are able to get data just based on the attributes. So what they do is, in Pathum there are two main concepts, if you can quickly look at it. First one is the EQL. So they have their entire query language there. What it allows you to do is that you can define the shape of the data. So that's where the syntax model comes into place. So you can go and say, hey, I want for a particular transaction this amount and this items information only. So it can go and it can fetch that data from the back implementation and give it to you. So what you can do with Pathum is, when you request that data, you are actually hitting the syntax model and you are asking for certain information. Then you can have resolvers. That is the second main thing that they have. So you can have those resolvers that can go and look into your semantic model as well, from where they will know from where to pull the data, and they can pull that data and give it to you. But the structure you are defining, or the syntax model that you are defining, is based on the application or based on the request or the API call that you are having. So the platform itself is not defining any fixed structure of the API that you need to call. You can define it, and that's the power that Pathum brings, and that's how it becomes very, very useful in this unified data model concept that we have. And they call it as smart maps also, because you can have a map in which you can define one field like ID, and you can ask for another attribute for that particular entity, and it can resolve it and get it for you, such that those maps looks like smarter maps because those keys are not defined upfront or not defined beforehand. So I'll show you one example of Pathum. The talk is not about Pathum, but I'll just give you a flavor of how Pathum works and how you can use it to get these attributes, connections, and values. So what I'm doing here is, it's a very simple example I'll take to make you understand that how exactly Pathum can work. So in the case of this example, we have a list of cities, and I put it in a database. It's just a files. And from that cities, if I specify any kind of a location, it is going to get me the name of the city, and from that name I can actually resolve and try to get a geolocation out of it. So how it works is, if you look at the implementation, so there are certain resolvers that you define in Patham, and in this case I am having a resolver called getting the geolocation from the city. So what it says is, if you have an attribute city, I can give you an attribute geolocation. So it's very simply you understand like that. And internally what I am doing is, I just have certain files, I get that location, filter it out and find the geolocation. Similarly, if I have an ID of the user and I don't have any other information, but I can ask for an age of a user, and that age can be fetched from the data. And similarly, I have some other resolvers also that I'll show. And what happens is, eventually to tell Patham what all resolvers you have a registry. So you can add all those resolvers in that. And then you prepare an index such that it knows which attribute that you are requesting, which particular resolver can provide it. So that kind of indexing is there in place. So if you look at it, what we can do is, if I'll just show you the data, how it looks like. So if you look at it, this is the data that we have. There are certain IDs, it's a type, is a location, and then you have certain names, and there is a geolocation as well. But when I am querying for it, I can just query it by a city. So I'm saying that the city is Pune. Yeah. Yeah, yeah. Yeah. So what we need to do is, yeah, what you said. You create a record, and now if you look at it, if I just try to print this location, you can see it just only has a city, right? But if I ask for a geolocation, that is where you can see that we have this resolver. So what it does is, if I ask for a geolocation, that key is not defined in the map. But what it will do is, it will try to find a resolver that can provide this key, and if it is available, it will try to get it. So this map doesn't have a geolocation, but if I ask for it, it will give me the geolocation. And now if I look at the location, you can see that that key is also available. So this is a very simple example just to show you that you can define what attributes you want, you can define the structure of your data, and at the back it can go and it can fetch this information for you. Okay. So this is how Patham works, and I have one example of the Patham also has a UI that you can look at. And what that UI does is, it can also show you nicely the entire structure of each of the attributes, how it is resolved and how they are connected. So I have a certain use case of retail similar domain model that I was showing you. So where I have different resolvers that can get your transactions by ID, and then from that transaction you can get the user information, location information, and you can get different items information that you have. And then this registry is what is registering all those details, and then indexes. And then finally I do initiate an environment. So if I initiate an environment in the Patham UI, you can see the entire indexes that is available, all the attributes that you have within the system. So it gives you a kind of snapshot of entire data set that you have. You can also look at the entire graph of how these attributes are connected. So you know exactly from when you are building this syntax model, from where exactly this data is coming. So entire lineage is available. And if I do any kind of a query, right, like for example, I ask for say this transaction information for this particular ID. So you can see it will get this entire transaction, and it will resolve all your items, everything that you need. So this is a very quick example of how Patham can work and how it will fit in. But actually in the implementation, this is how it comes together. So you have certain attributes and entities, and you have data around that. Those are your facts. So you can ingest it into any of the databases that support similar constructs. Like you have Datomic, Flurry is also coming up, and you have XGDB as well that are around that. So you can model and you can use these kind of databases to keep your semantic model in place. Then what happens is you can use Patham to either directly query these models and build the syntax models, or sometimes what happens is suppose you have to build a dashboard, and that dashboard needs a sub-second query to be addressed, right? That might not be satisfied by the semantic model or the databases that we are using underneath. So what you can do is you can use certain execution frameworks like Spark, Beam, or Flink, and then you can create those syntax models or realize those syntax models in a different database technology like your Snowflake or Elasticsearch or OpenSearch or any of these, which it can work with. But Patham can work with them as well. So you can use Patham to build your APIs to get the data directly from the syntax models, and that internally is connected to your semantic model. So entire thing is end-to-end connected. So if I talk about how everything comes together or how you can have this entire platform in places, you start from the left-hand side where you have certain pipelines. And in our case, we have built all these pipelines over Apache Spark. So you don't realize that you are using Spark, but it runs on top of that. And that execution engine is pluggable. You can use any execution engine there. And you ingest that data based on your domain model that you have created into a database. And that sections of those semantic models or data realization that you have, you can actually push it as a data pod. So you would have already be aware of Docker containers and these kind of containers. You can push that data into that, and Patham can directly query those containers. You can have very specific containers created based on your different business teams as well. So here the difference is each team can now work in isolation with this data set, but this data set conforms to your common unified model, right? So that's how you bring in the entire audit and validation there. And then you can create syntax model pods. It can be, like I said, Snowflake, Elasticsearch, whatever you want. And then your dashboard can directly use it. Your machine learning models can directly use it. And it is entirely connected back to it. So I'll show you a quick demo as well. Because whatever I am talking about, I need to show you that it works. So this is our Megbot platform. So whenever you open any kind of applications, you are welcomed with this screen. And in this screen, if you look at it, there are three parts: the left, center, and the right one. Left part is where you have all your data pipelines. And these pipelines are built once for source. They are not built by different teams in isolation. You build it once for the source that you are looking at. The centerpiece that you see is the attributes. So you only have to define your attributes first, right? Like I said, you're defining your semantic model at this level. So I have all these attributes, and you will look at it, we have around 10, 11 pipelines, but I'm able to represent that data in just 7 attributes. And that's the thing when the reality hits you hard, that because you have very varied way of naming, and it depends, the naming convention depends on the skill set of the least experienced person in your team. So if you standardize that attribute itself, you have come a very long way in the case of building such models. And on the right side is what you are seeing, entities. So why we define entities upfront is because you can directly relate it to the business. and you can define which particular attributes may be a part of it. So if I choose any of these entities, you can see which attributes are part of it, like ID is part of it, and it will take the data for this ID from this pipeline. Similarly, from this pipeline. Similarly, if I click on say transaction, you can see from where it is getting this data. So attribute set is the same, right? You don't have to define those attributes again and again. So once if you perfect your naming convention, that's it. You can use it across your organization without worrying about it. And once you build this in our domain data model or semantic model, you can call it, we can define all the relationships between the entities. And again, I'm saying that you look at this model and you know the application that I'm talking about, right? That's the power of it. If I would be showing you different databases, trying to show certain SQL queries and all, it will take a lot of time for you to understand. So here, if you look at it, you see that there is a transaction. And when you talk about transaction, it is connected to location, market, user, items. An item itself has a brand and it has a product. So if I go and try to look into transaction, right, you can explore this. And this data right now, we are using Datomic at the back. It is backed by Datomic plus Cassandra. So any data that goes into Datomic at this level. And Datomic is good for storing these entity information, but it may not be a very good choice for storing your events information. So what I meant by event is once you define your entities and attributes, you will see all the majority of the data sets, right? When we talk about petabytes of data, right? I have so many billions of records. Most of those records are just events that are happening around those entities, and they have a certain timestamp. So if you have a timestamp and these entity information, that is what your event information is. So Datomic may not be very good, the candidate for having that, but you can have certain other data source, right, or time series data source that can do that. But this is a semantic model, so you have your entities in place, and connectedness it is discovered. So you know, based on the relationships of your entities, these are the each data point that we are showing. And these data points are individual data points or facts that are there within the system, and you are also seeing the relationship between the facts. So this is very powerful because you can know, you can look into it, understand how they are connected and do it. But like I said, this may not be the only interface or only thing that you can expose, because in business, in enterprises, you have lots of tools, lots of requirements, lots of dashboards, different team using different technology, and we as a platform don't want you to box and say, hey, don't use that one, right? You use this. No, they can use. They are free to use. Snowflake was not there. Snowflake is now there. ThoughtSpot was not there. ThoughtSpot is now there. Tableau has been there. So they have been using these things, right? But if you tell them that you continue to use your application, we will standardize the entire data model at the back. And this is the advantage that you have, that today if you log into your system, you can see your entire data sets that is existing in your enterprise in one screen. And we went to one of the clients, they themselves were not aware of. Their data team started using our product, and now the power is in the hands of the executives, right? So CDO profile you would have heard of, right? Chief Data Officer. Chief Data Officer most of the time is spending in getting certain certifications, security certifications, or going to the team and asking, hey, tell me which data you have, right? Why can't the CDO himself or herself log into a platform and see what all data they have, how much compliance they have, how they're connected, right? So that's what you can do. And lineage, like I spoke about, if I click at this level, I can see the lineage up to the semantic data model, like what entities, attributes are there. Now, this is semantic data model, but like I said, you need to have syntax data model because that will conform to the structure that your external applications are having. So if I click on it, I go here, I went earlier into explore, so I am exploring at the semantic model level. I can stay at this level, I can choose what attributes I want. Like a demo I was showing you, very simple I showed in Pathum just to make you understand that technology exists. You can use it. I can choose what all attributes I want, and when I do and select, you have the entire data set in place. We didn't speak about connectedness, we didn't speak about joins, we didn't speak about pulling data from different sources. One click, the data structure, the entire structure is there. and I can either query this directly or I can realize it. So if I realize it, I can give it a view name, and I'll show you one of the realized set. So this is a realized set. This is entirely a syntax data model. But if I go into the lineage, earlier we were showing you the lineage till domain data model or the semantic model. Now you can see the lineage up to the syntax data model. All of them are connected. I can rename these fields. I can use whatever fields I want that you can do. But we will be able to track it back up to the source level of from where this data came into the system. And this is very powerful with the new laws coming in, and you need to get certain compliances in place. If you don't have this kind of data platform, whatever you do, it's a very, very difficult job to come to this level. Yeah, so that's what I wanted to discuss, and I hope that I'm able to take a part of the journey that I went through, and hope it all made sense, and you will be able to do good with data models going forward. Thank you. Any questions?
Said that we already built the data pipelines for ingesting data into the Gitomic or something. I'm just wondering how does what are the like actual sources of data for those semantic models? Like for example, you had a transaction, right? There has to be some way for that transaction to be recorded and then sent to your pipeline, which will finally go into Gitomic. So I'm just curious about that.
Yeah. So if you look at it, the pipeline that you have at this level, so all the pipelines that you build, right, if you expand it, you will see that how it is mapped to these attributes. So data can be in any place, right? It can be your CSV files, Excel files, SQL databases, any place where you have. So you need to build certain pipelines, and these are the different pipelines. We have this entire pipelining engine, no code, low code, that people call it. So you can build this. You have certain connectors there. You have certain syncs there. So all of that you can do it. So once you build this, if you push it into our FactorDB, we call it, that is the semantic data model store. And why we don't call it like a particular database, because you can use any database at the back. So all these pipelines are pulling that data, and it can come from any source. It doesn't matter. Only thing is it has to be mapped to one of the attributes that you have defined within the system.
Yeah, so what do you mean by building a pipeline?
Building a pipeline means you need to connect to a database,
Okay.
pull the data out of it, and if you want, you can do certain transformations on it, and then once you are fine, then you map it to an
So is it like, let's say there is 100 databases in an organization, everything needs to be pulled into one database, and you create a model out of it?
Yes. No, I mean, it's not like pulling everything at one place. So you are pulling all the semantic information like entities, attributes, all this information out of it, so that you have a certain standard defined.
So, but the data stays at one place.
Yes.
So why can't that be a graph database that is?
Yes, so it is a graph database. So if you look at the back, when I was talking about storing the semantic data model, it has to be a graph database, because then only it can have those connections.
Oh.
But graph database is not very good for events information or time based information,
Okay.
right? It is very good to keep the relationships and traverse it through that.
Okay.
So that's where we talk about that you can use certain execution engines to use this semantic information and existing data and create a time series database that can be then be a very faster access to your application. So that's where you go from semantic model to syntax model. but you should have the connection of where it is coming from, how it is connected to your business domain. So that you need to take care of.
So do you only use it for, like, let's say training models or engineering solutions as well? Let's say a fraud detection
Yes.
during runtime.
Yes. So you can have the entire machine learning models and everything built on top of it. So, but what we do is like our goal is not like building the machine learning models or do things for machine learning models. But as a platform, yes, we provide you an option to build models on top of it. And the benefit that you get in running the models on this platform, you can bring your own model as well, because we use at the back all these Kubernetes, Kubeflow and all these technologies. You can build your model as well. But the benefit that you will get is for that model from where the data is coming, you can track through this.
Okay, thank you.
Yeah. In your resolvers, you are not, I'm not seeing you are using namespace
Yes.
keywords, right? Or
Yes.
in backend also, is it developed in that way, like not using namespace? For example, food/ID or bar/ID.
Yes.
We are not using that, or
Yes.
how
No,
that?
the namespaces should be used. That was just
Okay.
an example that I had in Python. But you
No
should
problem.
you have to use namespaces because ID within a transaction, the ID attribute is same, but it's for transaction or for product or for user. So you need to have that.
Yeah, one more question, like the graph you are showing, right? It's from Pathom, or that's a different thing you are using? The graph connecting.
The connected graph that I showed you.
Yes.
This one. Yeah. So this.
I'm not seeing your screen actually.
Okay.
But fine, yeah, the structure, like, for
Yes,
example,
so,
yeah.
so that graph, what it is doing is it is firing a query directly on top of our graph database. That's the Datomic right now we are using it, and it is pulling that data and creating this graph for you.
And you mean like you are not, Pathom itself will provide us a graph database, right? You are not using that, you are,
The Python doesn't provide a database.
yeah.
It provides you a way to resolve your attributes. So the query that goes at the back is resolved by Python, but it hits the database eventually. So you need to talk the language of database only. But that conversion of what you are asking and then converting it to the language of database, that resolvers are doing internally.
Thank you.
Okay, thank you.